Hey there, we're about to do our last section in this chapter. We're going to talk about parent functions. So the first thing we're going to do is say, what in the world is a parent function? Okay, if we're talking about parents, oh my. All right, how do I determine how a graph moves with relation to its parent function on the coordinate plane? So basically what this says is that we're going to be able to look at an equation and say how it moves, like from its parent curve. So does it move up, down, left, right? Is it narrower, wider? Is it reflected, like turned upside down? All of that, not by doing anything mathematical, but just by looking at components of the equation. That's pretty slick, okay? So let's talk about quickly some key vocabulary. A family of graphs. It's a group of graphs that have a common shape, but they've been moved around. They've been moved around the coordinate plane, or maybe they've been widened or narrowed, okay? So something has been transformed on them. A parent graph is the simplest of all of the graphs in a family. I'm going to show you about 5 different parent graphs that you're going to need to learn how to recognize. And this is the graph that we compare to when we are discussing transformations. So if we say something is moving up 4 or to the left 3, it's in comparison to the parent graph. It's in comparison to the parent graph. And then a transformation, these are just the different movements around a coordinate plane. It could be a reflection, reflecting, dilating, which is stretch or compress, shifting left-right, which is called a translation, or shifting up and down, which is also a translation. So let's look at the graphs first. The constant function, f of x equals a. A is just a number, so that's y equals 5, y equals negative 2. The parent graph is y equals 0. It's a horizontal line. This one is also the x-axis. The domain is negative infinity to positive infinity, and the range is just simply 0 for this one, okay? A linear function, that's a slanted line. The simplest of all of them is f of x is equal to x. It has a slope of 1 and a intercept of 0, 0. Okay, here's my y, x and y intercept. Okay, the domain is negative infinity to positive infinity. The range, negative infinity to positive infinity. These don't have vertices, but you would talk about how the transform graph, the y-intercept changes. An absolute value function, we've been talking about that a lot. The parent graph is f of x is equal to absolute value of x. The vertex is 0, 0. The domain is negative infinity to positive infinity. The range, the smallest value is, the smallest y value is 0. So bracket 0, comma, positive infinity. The quadratic function, the simplest one of those is f of x is equal to x squared. Again, the vertex is 0, 0, right here. The domain is negative infinity to positive infinity. Notice the domain on all of these functions is negative infinity to positive infinity. The range on this one is 0 to positive infinity, and a bracket on that 0 because it includes that. A cubed function, f of x is equal to x cubed. This one looks like a chair. So if you ever see one that looks like a chair, then that's a cubed function. Its domain is negative infinity to positive infinity. Its range is negative infinity to positive infinity. Remember, this is an odd degree function. So it's both onto and one-to-one. Now we're going to start talking about the transformations. The first transformation is called a reflection. Anytime there is a negative sign in front of the right-hand side of the equation, what it does is it flips the graph over the x-axis. So turns it upside down. Look at this. I have a negative a. I have a negative x. These are all reflections. A negative absolute value x minus 2. A negative 3x squared plus 2. A negative 0.75 x cubed minus 10. All of these are reflections. Reflections. Why? Because there is a negative in front of the first term. The second transformation we're going to have is a dilation, okay? And this happens whenever there is a coefficient, we call it a, that's not 1, other than 1 in front of the x or the x squared or the x cubed, okay? This a changes the steepness, the width, the narrowness, but you have to remember, you ignore the sign of a because we already took care of that with the reflection. That's taken care of by the reflection. So taken into account by reflection. Okay? It's not that we don't look at it, we just call it something different. So you have a stretch. Dilation can be a stretch or a compress. Stretches or it compresses, okay? Stretch is steeper or narrower, and you get those when your coefficient is bigger than 1. Not equal to 1, but bigger than 1. So you see I've put all my coefficients in red. This is a dilation. This is a dilation. This is bigger than 1. 7 over 3 is like 2 1/3. Notice that this 2, I didn't highlight the negative in red because I don't care about that. That's going to give me, the negative will give me a reflection, but the 2 will give me a stretch. And a 10 will give me a stretch. A compression is something that's flatter or wider, and that happens when our a values are between 0 and 1. 0 and 1. So notice that I don't pay attention to the sign. I'm just worried about the value in front of it, okay? 0.5, that's less than 1. 0.15, that's less than 1. 0.25, that's less than 1. 2/3, that's less than 1, okay? Dilations do not affect the vertex or the y-intercept. Neither does a reflection. Yeah, reflection does. Shift left and right. This transformation happens anytime you have a number C, we just call it C for general, a general name for it, is added or subtracted from inside parentheses or absolute value bar. It has to be inside, capital inside. It's red, it's bigger than all the other words, it's underlined inside the parentheses or the absolute value. This has significant changes on the x-coordinate of the vertex. All right. Okay, so, and you have to think through this. A shift left is going to happen when C is added. Left is when you have a plus sign in between all of these. Okay, a plus sign in between whatever's between the bars or the parentheses. So let's look at some of these vertices. This is going to be negative 1.5, the new vertex, comma 0. That's what the new vertex is going to be. This one, the vertex is going to be negative 3, comma 0. Okay? It's shifting everything left 3, left 1.5, left 3, left 1. So my vertex is going to be at negative 1, 0. Okay? Now notice over here in blue, I have right. This is what's shifting right. Notice what sign that is. Right is whenever you have a negative. It's opposite of what we think, right? It's because we set whatever is equal to inside the bars or between the parentheses, we set it equal to 0. And we solve, and so it does that sign flip, okay? Notice that the C is inside It's inside the absolute value sign. It's inside the parentheses. It's inside the parentheses. It's inside the absolute value sign. It's inside the parentheses. It's inside the parenthesis. All right? So if we wanted to state how this moves, this is going to be right 3/5. So our vertex would be 3/5, comma 0. Okay? I'll tell you what's going to happen to get a change in the y. This is going to be right 2 units. So my vertex is going to be 2, comma 0. This is changing the x-coordinate of the vertex because it's left and right. This is right 1 unit, or my new vertex is 1, comma 0. Our final transformation is a shift up and down. So look for a number D. Oops. A number D, we just call it something different so we don't get confused. Oh, please, 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 please. A number D that is added or subtracted after the parentheses or the absolute value or anything being squared or cubed, okay? So notice what's happening here. The 5 is after the x. The 8 is after the absolute value. The 2 is after the x squared. The 1 is after the x cubed. Here, the -5 is after the x. The -7 is after the absolute value of x. The -2 is after the x squared. The -1 is after the x cubed. Okay, so if we wanted to talk about changing the vertex, this is changing the y-coordinate. So that means I have 0, 5 because it's 5 up from 0, 0. This is 8 up, so that's 0, 8. This is 2 up, so that's 0, 2. This is 1 up, so this is 0, 1. Okay, I'm doing single transformations, single, not multiple. We'll get to multiple in the next slide. This is down 5. This is up 5, up 8, up 2, up 1. This is down 5. So that means it's 0, and down 5 means my y changes, -5. Ordered pairs. Down 7. So this is 0, -7. Down 2. 0, -2. These are all the new vertices. The new vertices. V for vertice. Vertex. Down -1. Okay, now what we're going to do is we're going to put we're going to string transformations together. Okay, so describe the transformation and state the new vertex or y-intercept. So if you just have a line, it's going to change the y-intercept. All right, so do I have a negative out in front? Nope, so there's no reflection. So no reflection. Do I have a coefficient out in front? No dilation. Do I have a number inside parentheses? No shift left right. Do I have a number that follows the variable? Yes, so it's going to be shift down 2. Down 2. So my new vertex, or actually my new y-intercept, is 0, 2. Right, I'm going to do number 2 with you. Do I have a negative out in front? Yep, so I have a reflection. So I have a reflection. Oh, come on. Do I have a coefficient other than 1 in front of my x squared? Nope. So this is no dilation. Do I have a number being added or subtracted inside parentheses? Nope. So I have no shift left or right. Do I have a number being added or subtracted following the x squared or the x cubed or the absolute value? Yes. So I have a shift up 5. So it's going to be reflected and it's going to shift up 5, and my new y-intercept is going to be 0, positive 5. All right. So we'll go through number 3, and then I'm going to let you do number 4. Number 3, do I have a reflection? No, so no reflection. Do I have a dilation? Yes. I have a stretch because 2 is bigger than 1. Stretch. Can't spell, can't write. It's 11 o'clock at night. Okay, it's a stretch because A is bigger than 1. Do I have any left-right movement? No, so no left-right. Do I have up-down movement? It goes up 6. So what is my new vertex? Is 0, 6. All right. I'm going to do number 4 with you, then I'll let you do the ones on the other side, on the other screen. Okay, so I have a reflection because of the negative. I have a compression because 1/3 is less than 1. I have a shift right or left. Well, it's negative, so it's going to go right 3. I don't have a shift down, so my new vertex is going to be 3, 0. Okay. All right, I'm going to do 5, and I'm going to let you do 6. I'm going to do 7, and I'm going to let you do 8. So number 5, no reflection. I have a compression because 1/2 is less than 1. I have a shift right 5, and I have a shift down 3. So my new vertex is 5, 3. You try number 6, hit pause, and then come back. All right, hopefully you got the questions, the answers right on your video question. So here we go. This is a reflection. The 4 says we're a stretch. The -1 says we're right 1. The +3 says we're up 3. So my new vertex is 1, 3. Number 7, we're going to do this one together. I have a reflection because of the negative. I have a stretch because of the 2. I have a right 7. I have an up 4. So my new vertex is 7, 4. You guys hit pause, do number 3. X plus 3 times parenthesis x plus 3 cubed plus 2. Okay, hopefully you got the answers right on the video question. So I have no reflection. I have a stretch because 3 is bigger than 1. I'm going left 3, and I'm going up 2, and my new vertex is left 3 is -3 and up 2 is +2. So here's the problems we're going to work on in class tomorrow. That's not homework, that's your daily assignment. So thanks for listening, and I'll see you tomorrow.